Operating System Lab, experiment number 2. So here, so the first question was to find if a number is an Armstrong number or not using a function. So in order to do this, I've made a function called as Armstrong, which accepts one parameter, the value n. And if it is an Armstrong number, this function will return, uh, if it's an Armstrong number, this function will return true. Otherwise, it will return false. So that's why I gave the return type as bool. So here, if you can see, I declared a variable called sum, and I declare one more variable called test, which will be equal to n. And then it makes sum to 0, and like this sum will have uh, the it's not exactly sum. The like to find the Armstrong number, the formula is individual. Okay, um, the 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 sum of the use of the individual number should be equal to the actual number. So in order to have a constant variable for that summation process, I have the sum variable. So here I'm using a while loop and then passing this test as a value here. Until this test is greater than 0, this while loop will be executed. When it becomes 0, it will come out. So here, as you can see, I'm adding the value of this to the sum variable. I'm using the power function, which is there in the CMath library. And inside this power function, what I'm doing is I'm just using the modulus operator, like to is modding it by 10 to extract the last digit. And with that last digit, I'm just cubing the value of this last digit using the power function. So, and I'm just adding it to the sum variable. Then after this is done, then I do test by is equal to 10. What this will do is this will remove the last digit. Uh, like in terms of max, the decimal point will be moved once, like one step this side. So that variable will go because it's an integer. It's not a float. So eventually this test will be equal to 0. So that time the control comes off this while loop. Okay. If the sum is double equal to n, the total sum is double equal to n, then that means it's a Armstrong number. So I return 1 to indicate that it's true. Otherwise, I just return 0. So as you can see, I'm asking the user and the number to check if it's an Armstrong number or not. And here I'm using a like uh, here I'm using a conditional statement to see that if this returns true, this will be printed. If this returns false, this will be printed. So I will show you the result output. Just a minute. So we have put this. Yeah, now we can get the output. So I'm just compiling this file, successfully compiled. So x2 As you can see, it's asking for an Armstrong number. So 153 is an Armstrong number. I'll type it and see if it works or not. Okay, see, it turns true. Now let me give some other thing. So say 4, 2, 3, so this is not an Armstrong number, so it was false. So this is the first program. So move on to the second one. The second one, the second one is to use functions to return the square of a float number and cube of an integer. So for this, I've declared two functions with the respective data type return value. As we go return square, that means sometimes float might not be able to return the value. So I use a double to ensure that overflow like doesn't happen. And here for cube of an integer, sometimes this might overflow, so I use the long end. Here I just have an integer variable n, the float variable fn, and I ask user one integer and the float variable, and I get the value using the cn operator, and I just uh, call this function with the integer and the float and just see out the value input. So I will show you the output. As you can see, it's asking an integer and a float variable. So say let me give 4 as an integer. The float will make it 3.12. So as you can see, 4 cube is 64, 3.12 square is 9.734. The output is verified. So I will go on to the next problem. So the next problem is to find the greater. Okay. Uh, there are there are two digits given. The task is to find which one is greater. So I just used a function here which returns a boolean variable if the first one is greater or the second one is greater. If the first one is greater, return 1. If the second one is greater, return 0. So I'm accepting two variables as an integer. So if n minus n is greater than 0, greater than or equal to 0, that means the first one, the first number is greater. Otherwise, the second number is greater. I've included the equal to case. Um, as the question didn't ask for equal to case, I just included that as a part of the first number. So even if both the numbers are equal, it will be first number is greater. So here I'm asking using the two integers and then inputting that using the cn variable, cn command and storing it in NNN. Then I'm using a conditional statement to call this function with these two values. If it returns true, this will be printed. If it returns false, this will be printed. So I'll just show you the output. So as you can see, it's asking two integers. I'll give 5 and the 3. So as you can see, the first number is greater. Now show this again. The 3 and 5, second number is greater. So the output is verified. The last problem. Okay, the last problem is to return the total number of digits present using a recursive approach. So here I have a function which returns an integer, which is the total number of digits present in that integer. Say 500, there are 3 digits in that integer. So here I'm just inputting the value in, and I'm having a default argument, and this default argument will be used uh, like when you do recursion. So here the base condition is if n is double equal to 0, then we return the sum. If n is equal to 0, that means the entire uh, the like all the like that means all the bits have been counted. So here if it's not equal to 0, then we just increment sum and and do this operation. By doing n by 10, what happens is the last digit alone is removed. Say in terms of mathematics, a point shifts this side, and we have an integer, so the digits after the point will be erased. Only the digits this side will remain. And we increment sum and pass it as the as an argument. Then when all the digits are exhausted, will eventually become 0. That's when this base condition is activated and the sum is returned. So here I'm asking the user for a value and I'm inputting it and storing it in using the same command. Then I call the function which is here and just print it. Uh, a point to note here is I call it with only n. As is a default argument, it is not necessary that you need to use this in the function call. So I'm gonna compile it and I'm gonna show you the output. So here, as you can see, it's asking the number of digits. Say I give 500, it's written 3, so it's 3. I'll show you another example. I'll give 10,000, it's written 5. Uh, uh, okay, the max limit of this program should be around minus 10 power 5 and plus 10 power 5 as we're using integers here. So this is the last program, and thank you. Uh,